Hi, my name is Sergio and I'm going to explain PLA 11 rotator phases 2 and 3. So here we have the index. We are going to start with the phase 2 LCD display with the specification, planning and development and test. And finally we are going to finish with the phase 3. So here we start with the phase 2, the LCD display. Here we can see here we can see the symbol in the specification. We have the same symbol as P10 with the new feature that is the LCD display. So now let's go into planning. My files are in this repository. So as we can see here, the state diagram, we have the different states and we have the LCD display. Okay, so in the first row of the LCD display we are going to show the state. This is going to be changing. So in the second row we are going to have the number of rotations. This is going to change with the LCD flag goes 1. Okay, and the LCD flag is going to be 1 when we arrive to L0 or in the other way to the L6. So here in the planning hardware we have the chip. We are going to use the PIC18F4520. So as we can see here, all the connections are the same as P10 with the new feature that is the LCD display connected to the RD in pins. This is going to be reserved to the LCD display. Here in the planning software we have the output logic, the state logic, and is the same as P10, but now we have a new feature that is the bar LCD flag. This is going to be 1 when we arrive to L6 or L0, as I said before. And when this is 1, we are going to show the number of rotations, in the LCD display. This is new too. Okay, so let's go into the output logic flowchart. As we can see here, we have all the cases L7 to L0. In yellow we have the show state. We are going to show the state 7, 6, 5. Okay, this is going to be shown in the first row. And in case L6 and L0, when the bar LCD flag goes 1, we are going to write a message. Okay, here in the case L7, if the bar LCD flag is 1, okay, we are going to increase the number of rotations. We are going to show this in the second row of the LCD display, and we are going to clear this flag. So now in the development we can see here the rotator LCD. Okay, this is the parent sheet and this is the child sheet. As you can see, the new feature is the LCD display with the respective connections. So now we are going to develop the software, okay, in MPLAB using this chip to obtain the code file, and then we are going to do the test using using Proteus. Okay, first of all we are going to see the code. We are going to start with the init system. Okay, here we have the first changes. Here we have the LCD initialization. This is new. Okay, then we are going to go here. Let's have a look of the state logic. As you can see, is the same as we have done in P10, but the difference is in output logic. Okay, here in the case L6 and L0, as I said before, we have the bar LCD flag in 1, and the other cases bar LCD flag is 0. Okay, when bar LCD flag is 1, in the case 7, we're going to do an if, and we're going to put a 1 in rotations. Okay, and this is going to increment. So in the first row we are going to put the number of the state. Okay, in L7 we are going to put state 7, L6 state 6. Okay, and that's it. So now let's going to have a look on the simulations. Okay, if we go debugging, okay, this goes changing the state, the rotations is 0, and when it arrives to state 0, as you can see, this is in state 0, the bar LCD flag is 1, and when it's 1, Okay, here the counter rotations increase. So now, as we can see, the bar LCD flag is 0, and when it arrives to state 0, goes 1 another time, okay, and the bar counter rotation goes increasing. Okay, so let's click play. State 3, 1, 2. We can click the clear counting enable. This stops, and if we click here, we can see goes in the other way. So that's it. That's my phase 2 of the project. Okay, so now let's continue with the phase 3, implementing the timer 2. Here we have the symbol in the specification, we have the rotator, but this time without the external CLK. This continue as phase 2. Now in the planning we can see here the same schematic as the same state diagram as before, and now we have the bar timer flag, despite the bar CLK flag. In the planning hardware of the chip, here we have the connections as before, and here we have all the LEDs, RD reserved for the LCD, and now we can see that we don't have the CLK connections. Now in the planning software we can see here the internal architecture of the timer 2. Here we have the pre-scaler, the timer 2, the post-scaler, and another post-scaler, the N4. Okay, so I'm going to use 4. I need this TP, so my N values are going to be these ones. Okay, so here we have the planning software. Now we have the bar timer flag inspired the bar CLK flag. Now in the development, we can see the parent sheet is this one. Here we don't have the CLK, and I have added a timer wave to see the wave of the oscillator, the internal oscillator, the timer. So here we can see the child sheet. Here we have the connection for the timer wave, and as you can see here, now we don't have the external CLK. Now I'm going to explain the C code. Simulation is done with this microchip, and then I'm going to show a test using Proteus. Okay, so in the C code we are going to see only the things that have changed. Okay, so now we have the initializations of the timer 2. We have a different interrupt service routine. Here we have the conditions for these works, okay, and in write outputs we have this code to show the wave in Proteus. Okay, what's more, here in the init system we have all the initialization of the timer 2. This is new 2, and these are the values that are used to obtain the reserve TP. And finally we are going to finish with the simulation. So let's see, here we have the wave. Let's see what happens. Here we have the time, and let's see what happens here. Okay, here we can see how this goes rotating. The LCD works correctly, it counts the rotations too. We can put the counting enable to stop the system. Let's run again, and we can change also the orientation of this. This is going right, and now it's going left. Okay, so now clear direct. Let's see what happens. It starts again. So thank you. To conclude my project, I have learned how to use a LCD display to show all information and to use a variable to not overcharge the display, and then I have learned how to use internal timer 0 and timer 2 of the chips. Okay, thank you, that's my project, and goodbye.